Welcome to the garage. I'm Robert, and this is Haslip Cycle Works. Today's episode will be part 3 of our Vulcan 750 Cafe Racer build. Today we're going to specifically target working on our Cafe Racer seat frame. I introduced the parts in the previous video, and what we're going to do today is we're going to extend our frame. It's probably easier if I just show you. So we still have our seat, still in the cell thing, still protected. Set this over to the side. And we have our frame hoop with the integrated LED. The LED's over there. That won't be installed until probably after paint or powder coat, whichever way we go. But as you can see, let me adjust you guys here. As you can see, this hoop's just a little short, and that's fine. What we're going to do is we're actually going to extend this, and I have off camera a couple pieces of tubing that match this. We're going to slug this and weld on our extensions today, and we'll go over the way you can do that safely and the different types of tube that you could possibly build this out of, specifically mild steel tube. We're not going to get into the chrome moly discussion or anything like that, although if you have that available to you, by all means. The thing to remember about chrome moly though is if you heat it up via welding, there is a process afterwards that you have to complete for it to maintain those specs and rigidity that you were targeting in the first place to go with chrome moly. So just keep that in mind. Maybe we'll have a metal lesson in a future episode, but today we're going to focus on the seat frame and extending it out. Let me get the seat out of the way. And these are our extensions. Clearly overkill for what we need. In the metal world, it's better to have it longer than what you need and cut it back than it is to try to weld back onto this. And it's just quicker and easier that way to cut it back to where you need versus trying to add to it. And it probably goes along with pretty much anything. Wood, plastic, whatever your medium is. So let's talk about how we're going to join these extensions to the seat hoop. So what you may see a lot of guys do, and it's not wrong. You can do it. Is it the safest? No, not so much. As you can see, this tubing is not that heavy wall. Now when we talk about wall, we're talking about the thickness of the tube. As you can see, it's not that thick. So just doing a butt weld like this, just go ahead and welding that together. Well, that'll work. I don't know about you guys, but if I'm going to be parking my butt on this thing and doing highway speeds, I want to do it as safely as I possibly can. So, tread at your own risk here. The way that I am going to do this is with a slug. And all a slug is a piece of round stock. You can go solid, or you can go like we're going, another piece of tube that has an outside diameter that closely matches the inside diameter of our primary tubes. So the goal here is to slide this guy in here, slide this guy in here, and two main hoop pieces butt up against each other, and we weld it together. It's a little more involved than that, but that's the premise. As you notice, if you look at the measurements on the specs for these tubes, this should fit right inside of here, but it doesn't, and here's why. If you look, I don't know if you guys can see that or not. but there is a little ridge right where my fingernail is. And that is due to the process of which this tube is formed. In the mild steel tubing world, there are two main ways to essentially build tubing. One, which we have here, is ERW, and that is electric resistance welded. So what they'll do is they'll take essentially a sheet and they will roll it over, and then it gets welded together. So it has a seam, and there's a very slight flat spot where that seam is. But of course, as you're welding it, your base material comes through the back, and you get this little ridge in here. The other tubing that you could go with, which would avoid that altogether, is called DOM, or drawn over mandrel. All drawn over mandrel means is that the pipe, or sorry, pipe is not the correct term, and that's something that you need to watch out for. Piping is measured differently than tubing. Not pertinent to this conversation, but when you go to buy something for your motorcycle, you're looking for tubing as far as the frame goes, not piping. Piping is for plumbing. Tubing is for anything else. All right, back on topic. DOM means drawn over mandrel. So what they'll do is they'll take the metal and draw it over a form. So there is no seam. Wall thickness is more consistent. It's smoother. You don't have a flat spot or any seam, and you don't have the ridge on the inside of the tube. There is a cost difference, though, between the ERW and the DOM. If you see a big price difference between two pieces of tubing with the same measurements, guaranteed one's going to be ERW. The other, more expensive option will be DOM. DOM will definitely work here, but there's absolutely nothing wrong with ERW in this case. Now, if this were like the backbone of the bike or something like that, then DOM and probably chrome moly would probably be the way we would go. But for something this small that is not a stressed member, aside from our own weight, this will be fine. Mild steel, ERW. So if you're going to slug, and I believe that is the correct term, two pieces of tubing together with another piece of tubing or with a piece of solid round stock, how do you deal with that little ridge? Well, there's no real easy way to do it. You're gonna have to bust out your grinder, like a pencil grinder or a Dremel or something like that, and whatever the length of this tube is, that's going to be inserted in here, and you're going to have to grind that weld off. There's just no two ways about it, unfortunately. But like I said, if you want to spend the extra money, or if it's necessitated, DOM will allow you to drop this right in, be a done deal. This particular slug for our case is a little long, so I'm going to trim this down, and I'm just going to do that on the bandsaw off camera, and I'll get our Dremel set up and show you how we take care of this and how it's going to fit. What I've done is cut those 3-inch long slugs down to 1.5 inches, and you can see that's going to give us plenty of material there, and that'll be a nice safe joint. So what we need to do, now we've got our slugs cut down, is clean up that ridge on the inside of here. Like I said, I'm going to use a Dremel with a stone on it. You can use the sanding discs, whatever you have, anything that you can use to get in here and to get rid of that ridge. We want to insert this slug roughly half of its total length into this tube. That's about where we need to clear that ridge to. Give yourself a little extra just to be safe. Yeah, hand file or whatever you have to get down in there to smooth that ridge out. Otherwise, you're not going to get this in here. Do not force this slug into your tube. If you do, it's going to bow the tubing out. And it may look fine, but once you get it all metal prepped and painted, you're going to see the tube's going to look wavy. And you don't want that. You take your time, do it right, do a quality job, and you'll never have to second guess it. I'm going to fire up the Dremel here and get to work. Alright, so we're ready for our first test fit. There we go. So it's in there. Doesn't take too long. You don't want to take too much from the wall of this tubing. So be careful and pay attention to what you're doing. And what you want to do, it doesn't have to be super accurate, is mark roughly halfway so that when you insert this guy, you know you're in there far enough and you're not going to screw yourself over and only leave yourself a little bit left. Be careful if it's still a little tight to get in there. Do a little more cleanup, maybe even sandpaper to the outside of your slug, because you don't want to push this thing in there and then have to take it out and you can't get the damn thing out. So pay attention to that. Remember, nice, a solid fit, but not so tight that you're gonna blow this tubing out and make it look ridiculous. All right, so what I'm gonna do is the same thing on all ends of our, and then I'm going to bevel these edges on the belt sander. And anytime you weld anything, that's critical. You definitely want to bevel it so that you can get some good solid penetration. We don't need to do both ends because we are going to end up cutting this once we get it kind of mocked up and measured. And the other end that goes on the bike that joins the two down tubes. The Vulcan's kind of unique that instead of a single down tube, it has two down tubes. Complicates things a little bit, but nothing we can't overcome. So what I've actually done to make it a cleaner setup and a little more solid is I've ordered another pre-bent seat hoop, same dimensions and everything. It just doesn't have the LED cutout, and we're going to put that on the other end, and we're going to put two notches in that match those two down tubes, and we'll weld that to the bike. But I don't have that yet, so we'll continue working on what we've got. Our Dremel's made short work of that ridge. As you can see, got our slug in. Piece is made up pretty nice. Now, you may be asking, what good is that slug if it's not attached? That'd be a good question. So if we were to just go ahead and weld this, if we didn't get full penetration into that slug could vibrate out and find its way down the tube, or just sit there and rattle. Excuse me. So what we're going to do is what's called a rosette weld or a plug weld. And what we're going to do is we'll measure down from the edge of our tube somewhere in the middle of that slug. We're going to drill a hole, one on the top, one on the bottom. We're going to set our slug in there. We'll chamfer that hole, set our slug into its correct depth, and then we're going to fill that hole with weld, and that will permanently attach that slug to this tube. And we'll do the same thing on our seat hoop, hole in the top and bottom. We'll push the two together, fill in those two holes, and then run a bead around the tube, making it one solid piece. So now you see why this slug idea, it adds so much strength and rigidity to the setup. So I don't want to bore you guys too much. I'm going to go ahead and measure these and mark them and center punch, and then drill our holes that we will use for our plug welds. And I'll bring you guys right back. Got you guys back. What I've done is cleaned up anywhere where we're going to be welding, inside and out, on our tubes, and I've wiped it down with acetone. On our slugs, I've hit those with a Scotch-Brite pad just by hand and wiped those down with acetone. Our holes are cleaned up, our edges are beveled, holes chamfered. So at this point, what we're going to do is insert our slugs halfway into our extension tubes and kind of tack that up, and then we'll insert what's left of the slug in the extension tube into our seat hoop and weld that up. We're going to use our Surflat weld table to make sure everything stays nice and true and straight. We don't want to weld these extensions on and be out a couple degrees and just throw everything off. So we know this thing is flat and true, so we'll go ahead and use it. Clamp everything down, and what we'll do to align these is I'll use the edge of this tube to hold this up off the table. That way our slug doesn't go in crooked. I'll mock up one side real quick and show you guys what I'm talking about. Okay, so what I've done is insert our slug to the halfway point into our extension tube, and you can see it through the hole there. And what I'm going to do is just set it in to our seat hoop. Don't want to push it in. We don't want it to drive it down any further. We just want to get that gap consistent. There's a little bit of a gap, so you want that consistent. If you were to weld this slug into that tube and just relied on the fit, it may be a little off. This way we know it's straight and we know it's true. So we've got our initial weld done. It is a little concave, which is fine. So now that we know that we've got our slug in our tube, we can go ahead and slide the remaining amount of the slug into our seat hoop. So we've got it in there, and the reason why we clamp this, definitely look for a video coming up soon where I want to show you just how much metal moves when you put a lot of heat in it. But we want to clamp it down. That's not going to keep it from bowing, but it will keep it from bowing as much and blowing this thing completely out of skew. But we'll put our 1, 2, 3 blocks up against it. It's still straight. It's nice and flat on the table. So we'll go ahead and weld that in. And now we'll flip it over and do the other side. Sorry if I bumped you guys. And I'm not sure if you guys can see it, but there's a little bit of smoke rolling out of the tubing where the LED light goes. And that is exactly why when you go to TIG these tubes, or any tube, you make sure they're clean where you're welding, because there are oils and all sorts of who knows in these tubes. You don't want that screwing up your weld. I'm not sure if it's coming across on camera, but you'll see what the whole purpose of the argon is. As I'm welding, the liquid metal is silver, as you expected. When the gas post-flow stops flowing and it no longer provides an atmosphere, protective atmosphere for that molten fluid of metal, you'll see it change colors. But we'll get more into that when I do that video about how much the heat will actually move the metal around. It's pretty cool stuff. Let's keep going. Get the other side all clamped down and we'll do the same thing there. So just like before, I've got our slug welded to our extension. I'll go ahead and push it all the way into the actual seat hoop. Our plug welds are 90 degrees out, and we'll clamp this down and we'll get it all welded. Our plug welds are done. Our slugs are stuck in our tubing. Now what we're going to do is weld that little gap right there on both sides. And this is one solid piece of metal. Fire up the angle grinder and smooth these back and blend them in. after hitting it with the angle grinder with the flap disc, we've got it pretty much evened out. Don't want to put too much time into it right now. We still have to cut these extensions to our length we need, and then we're also going to have to slug this end and put our other U-turn piece on once it comes in. I have not received that yet. But I will go ahead and set the seat on here just so you guys can get a better look at how it's going to be. Here it is, out of the cellophane for the first time, sitting on our frame. Every time I look at this seat, I'm just amazed at how good it looks. This thing's going to look amazing on the Vulcan. I think that's it for today. Still waiting on that front U-turn piece to come in. I don't want to cut these extensions yet for fear of cutting them too short. That wraps it up for today, guys. I'm going to show you one more thing. So, coming off the tank, clearly it's too long, but just imagine the front of the seat up against the tank, and you can kind of see how we're going to look. This does have, I think I measured, it's like a 3-degree upsweep, which isn't bad. May need to adjust that a little bit, but we also need to notch this frame here to match so that this sets down into it. So that may bring it down to flat with a 0-degree upsweep. And then we're going to come up with something cool here as a gusset. But you get the idea, right? That's going to look absolutely sick. Imagine that LED light in there with those gold shocks. It's going to be one mean looking Vulcan. Until next time, get up, get out there and do it.